Hello, my dear students. Welcome to IK Sir Chemistry classes. Here we are in lecture number 8 on the chapter Symmetry and Group Theory. In this video, we will discuss mathematical group. Now, the question arises, what is group? Any collection of numbers or symbols constitute a group in mathematical sense if they obey a set of four rules. It means a collection of numbers or symbols constitute a group in mathematical sense if they obey a set of four rules as discussed in the later slides. The members of a group are called the elements of the group, and these four rules are discussed one by one. The first one is the law of closure. The product or the combination of any two elements of a group and the square of each element of a group must belong to the same group. It means the product or combination of any two elements of a group as well as the square of each element of a group must belong to the same group. The law of combination may be addition, subtraction, or multiplication division, and it must be specified. It means which type of law of combination is applicable to a mathematical group must be specified, and the law of combination of a group is called group operation. The mathematical group may simply be called group. A collection of symbols or numbers constitute a mathematical group or a group if they obey a set of four rules, and the first one is the law of closure. Let us illustrate the law of closure. Let A and B be two elements of a group G. We consider a group G whose two elements are A and B. It means the element A belongs to group G and the element B also belongs to group G. Then the product of the combination of elements A and B must belong to the same group. At the same time, the square of element A must belong to the same group, and the square of element B should also belong to the group G. It is law of closure. The product or combination of any two elements of a group as well as the square of each element of a group must belong to the same group. The second law is law of identity. There must be an element in the group which commutes with all other elements and leaves them unchanged. In a mathematical group, there must be an element which commutes with all other elements and leaves them unchanged. And it is customary, it is convention to designate this element with the letter E, and it is usually called identity element. There must be an element in a mathematical group which commutes with all other elements of the group and leaves them unchanged, and this element is called identity element, and it is denoted by the symbol E. Symbolically, we can define it by writing E is the identity element, X is any element of the group, and if any element of a group is multiplied by identity element, it will remain unchanged. At the same time, the law of commutation holds good. It means E into X is equal to X. At the same time, X into E is also equal to X. Let us illustrate the identity element. The number 0 is the identity element in arithmetic when the law of combination is addition. For example, 5 plus 0 is equal to 5. If this identity element is added to any other element of mathematical group in arithmetic, it will remain unchanged, and law of commutation holds good. 5 plus 0 is equal to 5, as well as 0 plus 5 is also equal to 5. The number 1 is the identity element in arithmetic when the law of combination is multiplication. Please note that in arithmetic, 0 is identity element when the law of combination is addition, while 1 is the identity element in arithmetic when the law of combination is multiplication. Let us illustrate it. 5 multiplied by 1 is equal to 5. If this element is multiplied by identity element, it remains unchanged. At the same time, the law of commutation holds good. 5 into 1 is equal to 5, as well as 1 into 5 is also equal to 5. And the third law is law of inverse. The inverse of each element of a group must be the element of the same group. It means if A is the element of a group G, then the inverse of element A, that is A inverse, must belong to the same group. An operation always commutes with its inverse, and the product of two is E. Any operation, any element of a group commutes with its inverse. Any element of the group commutes with its inverse, and the product of these two is equal to E, identity element. We can say that in symmetry group, any symmetry operation always commutes with its inverse operation, and the product of these two is equal to identity. Here, A multiplied by its inverse is equal to E. At the same time, the law of commutation holds good. A inverse multiplied by A is also equal to E. Let us see the law of inverse. The inverse of each element of a group must belong to the same group. If A belongs to a group, then its inverse will also belong to the same group, and the inverse of an element of a group always commutes with it, and the product of these two is equal to identity. Let us illustrate the law of inverse. In arithmetic, the inverse of 5 is 1 by 5. If the group operation, if the law of combination is multiplication, 5 multiplied by 1 by 5 is equal to 1. If an element of a group is multiplied by its inverse, the product is equal to identity element. And the law of commutation holds good. 5 multiplied by 1 by 5 is equal to 1. At the same time, 1 by 5 multiplied by 5 is also equal to 1. On the other hand, the inverse of 5 is minus 5. In arithmetic, the inverse of 5 is minus 5 if the group operation, if the law of combination is addition. For example, 5 minus 5 is equal to 0. When the law of operation, when the law of combination is addition, and that is the group operation is addition, the identity element is 0 and 5 added to its inverse is equal to 0, and the law of commutation holds good here also. 5 minus 5 is equal to 0, or minus 5 plus 5 is also equals to 0. And the fourth law of for a mathematical group is law of association. The law of association holds good among the elements of a mathematical group as found in ordinary algebra. For example, 5 plus 3 plus 9 can be solved in two ways leading to the same result. 5, first of all, 3 and 9 are added, and the result of this addition is 12. Then 12 is added to 5. The net result is 17. Then first of all, 5 is added to 3 and its addition is equal to 8. 8 plus 9 is again equal to 17. Similarly, the symmetry operations A, B, and C can be multiplied in two ways, giving rise the same result. First of all, B is multiplied by C, and then this product is multiplied by A, and the result will be same if A is first of all multiplied by B and thereafter this product is multiplied by C. This is called law of association, and this law holds good among the elements of a mathematical group. The symmetry group is a mathematical group. First of all, we will see what is a symmetry group. The complete set of symmetry operations that can be carried out on a molecule is called a symmetry group. The complete set of symmetry operations that can be carried out on a molecule is called the symmetry group. And the symmetry group is a mathematical group. That is, the symmetry group is a group in mathematical sense, and the symmetry operations are its elements. The complete set of symmetry operations that can be carried out on a molecule is called a symmetry group. It is a mathematical group and its symmetry operations are its elements. The symmetry operations of a symmetry group obey all the four laws of a mathematical group. The elements of a symmetry group, which is a mathematical group, are symmetry operations, and they obey all the four laws of a mathematical group as discussed earlier. Now, there is a special type of mathematical group which is called Abelian group. The mathematical group in which all the members commute with one another is called an Abelian group. The mathematical group or the group in which all the members commute with one another is called an Abelian group. It means the result of applying the group operation on any two group elements does not depend on the order in which they are written. The net result of applying the group operation to any two group elements does not depend on the order in which they are written. Let us illustrate it taking a few examples. In a group of whole numbers, the elements commute with one another if the law of combination, that is group operation, is addition or multiplication. In arithmetic, if the group operation or the law of combination is addition or multiplication, then the elements commute with one another. For example, 5 plus 3 is equal to 8 and 3 plus 5 is also equal to 8. It means the law of commutation holds good and it is a group which is an Abelian group. Similarly, 5 multiplied by 3 is equal to 15 and 3 multiplied by 5 is also equal to 15. It means the group in arithmetic is an Abelian group if the law of combination, that is group operation, is addition or multiplication. These numbers commute with one another. And cyclic group, the mathematical group which is generated by a single element x is called a cyclic group. The mathematical group which is generated by a single element x is called a cyclic group. And this single element is called group generator. The other elements are obtained by giving different powers to the single element x. The cyclic group is essentially an Abelian group. It is also called commutative group. The Abelian group is also called commutative group. Let us illustrate it. Let us illustrate cyclic group. The Cn point groups are cyclic groups. Let us see an example. C5 symmetry group. Its symmetry elements, the elements of C5 symmetry group. The elements of C5 symmetry group are the symmetry operations present in this symmetry group, and these are C5, C52, C53, C54 and C55, that is E. These are the symmetry operations present in C5 symmetry group, and hence these are the elements of C5 symmetry group, which is a mathematical group, and all these elements are generated by a single element C5, and these have different powers of C5. Here C5 is group generator, and the law of commutation, we have already seen that the cyclic group is always an abelian group and its elements commute with one another. For example, C52 multiplied by C53 is equal to C55 and its result is E. And the same result is obtained if C53 is multiplied by C52. It is again equal to C55, that is E. Therefore, Cn point groups are cyclic groups. The cyclic groups are always abelian groups. In cyclic group, there is an element which is repeated several times. It is called group generator. In C5 symmetry group, C5 is group generator and different elements are obtained by providing different powers to this C5 element. Thank you for watching the video with concentration. Please like and share it. If you have not subscribed my channel yet, subscribe it so that you may get information regarding my new videos in time. Thank you again.